this session. All right, next point. To lift an apple upwards by 1 meter requires 1 joule of energy. Okay, or so your 1 meter किसी भी चीज को उठाने में, okay, 1 meter उठाने में जितनी energy लगी, that is 1 joule of energy. Okay, now 1 kilojoule. Now you know what is metric system, right? So if I say kilojoule, that means 1000 joules.
Right. Yeah.
Okay. If I say megajoules, that means 10 raised to power 6, यानी कि 6 zeros. 1, 2, 3, 4, 5, 6. 6 zeros. Okay. So you should know the conversions, all right, which we will be using very often. अब देखो यहाँ पर लिखा है other units of measurement examples, all right. So let's say 4200 joules is 1 calorie of food. ठीक है. So to burn, आज केक खा लिया बहुत सारा, so to burn that calorie, कितने joules of energy हमको कितने किलो joules of energy हमको burn करना पड़ता है? Can you imagine this now? Okay, 1 megajoule. 1 megajoule. आप समझो Mars, you've seen that chocolate Mars?
Yeah.
उस chocolate का energy, that is 1 megajoule. Okay, usually इनके ऊपर calories लिखी होती है, how much calories you are taking in. But you understand that 1 calorie is 4.2 kilojoules. So अगर आप एक bar of Mars खा लिया आपने, so how much energy it is, right? Okay. This is just like a kind of comparison. अभी आप देखो ये कितना joules है, बहुत कम है ना? Joule is not a very big unit, huh? So this is a very small, वैसे भी value is very small, very small than 1. Energy need to produce a syllable of a word. That is the energy that you're spending when you say 1 syllable. Okay. Okay, this is the amount of energy that you utilize. That's too less, right?
Yeah.
Okay. Then comes so many zeros. How many zeros? बताना जरा मेरे साथ count करो. 3 into
7.
So how many zeros? 21 zeros, huh?
Yeah. I counted it like in batches of 3.
So 3 sevens are 21. So how many zeros? It's 15 into 10 raised to power 21 joules of energy received by Earth from the sun in a day. So you can imagine kind of understanding आई थोड़ी joules क्या होता है, right? Now another important statement which we use, Argun, camera on, unmute.
Yes, sorry, I was just adjusting myself.
Now we come to conservation of energy. What does conservation tell us? Energy can neither be created nor be destroyed. It will always be transformed from one form to another. Okay. Conservation of energy also means that the total energy in the universe in a system is always constant. Okay. In the universe or in any closed system. कि अगर हमने किसी भी सिस्टम, एक ऐसा कोई भी सिस्टम ले लिया जहां से एनर्जी हम बाहर नहीं जाने दे रहे, तो इसके अंदर ही सारी एनर्जी घूमती जा रही है. इट्स कॉल्ड अ क्लोज सिस्टम. दिस इज अ क्लोज सिस्टम. सो इसमें एक फॉर्म से दूसरे फॉर्म में कन्वर्ट होता रहेगा, लेकिन इससे बाहर नहीं जाएगा. सो व्हाई इट इज सेइंग यूनिवर्स, कि यूनिवर्स में अब जितनी भी एनर्जीज होंगी वो एक फॉर्म से दूसरे फॉर्म में कन्वर्ट होती रहेंगी, बट दे विल नेवर डिस्ट्रॉय. ठीक है. दे और इट कैन नॉट बी क्रिएटेड ऑल्सो. आप एक फॉर्म को दूसरे फॉर्म में चेंज कर सकते हो, खत्म नहीं कर सकते, या अब नया नहीं क्रिएट कर सकते. क्लियर?
Understood.
Okay, now let's look at the pendulum. पेंडुलम का ये पोजीशन, आपने इस पेंडुलम को पकड़ा और ऊपर ले गए. ठीक है. अभी क्या होगा? What will happen, Sargun, at this point?
When you leave it, it will go over like that.
At this point क्या है situation? You have raised it. तो आपने क्या बढ़ा दिया इसका? Come on. You know it. मैंने आपने किसी चीज को रेज किया तो उसकी हाइट बढ़ती है कि नहीं बढ़ती है?
Yeah.
और जब हाइट बढ़ती है तो उसको क्या बोलते हैं हम? विच एनर्जी इज इट? ओके गौरी,
Gravitation.
sorry, say it again. I lost you in between.
Yeah. Gravitational potential.
You raise the height, so it is gravitational potential energy. Now, यहाँ इस पोजीशन पे मैक्सिमम क्या है? ग्रेविटेशनल पोटेंशियल एनर्जी, क्योंकि अपने मैक्सिमम हाइट पे है. कीप दैट इन माइंड. हाइट यूज करते एनर्जी कौन सी है? ग्रेविटेशनल पोटेंशियल एनर्जी. क्लियर? नाउ अब क्या होगा? एट दिस पॉइंट काइनेटिक एनर्जी कितनी है? 0.
Zero.
जब ग्रेविटेशनल पोटेंशियल एनर्जी मैक्सिमम होगी, दैट मीन्स वो अपने मैक्सिमम हाइट पे जा चुका है और वो अब फर्दर आगे नहीं जाएगा. मूवमेंट बंद. फॉर अ पॉज, देयर इज अ पॉज. व्हेन देयर इज अ पॉज, मूवमेंट बंद हो गई तो काइनेटिक एनर्जी क्या होगी सरगुन?
The movement, it will be 0.
इट विल बी 0. सो एट दिस पोजिशन, मैं वापस पूछूंगी, ध्यान से देखना है ये चीज को. पेंडुलम इज अ वेरी इंपॉर्टेंट थिंग. इस पे बहुत क्वेश्चंस होंगे पास पेपर में. ठीक है? सो at the highest point, gravitational potential energy is maximum. Kinetic energy is
Minimum. Zero.
minimum or 0, right? Okay. बीच वाले पोजीशन पे आ गए. क्या हुआ यहाँ पे? क्या हो गया?
It's the lowest it can go, right? So
लोएस्ट
the
हाइट हो गई.
gravitational potential energy will be very less.
मिनिमम हो गई या 0 भी हो सकती है? 0 भी हो सकती है. ठीक है? सो ग्रेविटेशनल पोटेंशियल एनर्जी एकदम मिनिमम, बट काइनेटिक एनर्जी एट दिस पॉइंट इज
Maximum because
बिकॉज
it's
जितनी पोटेंशियल
moving.
एनर्जी थी वो पूरी कन्वर्ट हो गई काइनेटिक में.
Right.
ठीक है? अब सरगुन यहाँ समझ में आया? सरगुन, इस
Yes.
पोजीशन पे क्या था? ये पोजीशन पे क्या था?
The gravitational potential energy was at its most, like maximum,
राइट.
and
एंड
kinetic energy was 0.
एट दिस पोजीशन अभी क्या है?
The gravitational potential energy is like almost, it might be 0 also, and the
Right.
kinetic energy is the most, like it's at its maximum.
ओके. नाउ एट दिस पॉइंट गौरी वापस क्या हो जाएगा?
Again, gravitational potential energy will be at its maximum because it's at its maximum height,
राइट.
and kinetic energy will be 0 because it's
Will be 0. What if my point is my pendulum is somewhere neither at the mean position nor at the highest position? अभी यहाँ पर है कहीं पे.
then I
नीचे.
think maybe the gravitational potential and kinetic energy will kind of be in balance, like
Will
maybe
be in balance.
equal.
Yes.
Equal.
Yes. Middle between, यहाँ से यहाँ तक के बीच में जो भी पोजीशन होगा, मिडिल में जो भी पोजीशन होगा, although what I made is little towards the higher side, but I meant in middle. So वहां पर क्या होगा? You will see that यहाँ पर kinetic energy is same as potential energy. Clear? Clear है हमको? ठीक है?
Clear.
So pendulum is clear. Very nice. इस पे बहुत क्वेश्चंस होंगे पेंडुलम से बेस के बेस्ड.
Yeah, we've seen lots of questions with pendulums.
Pendulum, yes. So, okay. What about the total energy of this entire system? Pendulum oscillation का पूरा सिस्टम जो हम देख रहे हैं, what will happen to this? Suppose मैंने ये पेंडुलम को वैक्यूम में मैं लेके गई और ये पहले अपने रूम में लेके रखा. ठीक है? पहले यहाँ अपने रूम में रखा है, तो मैं इसको बस पुश कर दिया और तो क्या हो जाएगा? After some time, what will happen?
It will stop moving.
It will
It will
stop.
come to rest.
Why?
Because there are other forces also acting on it, not only gravitational potential and kinetic, like there
And
might
what are
be
those forces?
air resistance.
Air resistance and air friction, whatever friction that
Friction, yeah.
right.
So
right?
then
air,
ultimately it slows it down.
it is close. It slows it down. And हम जब conservation of energy पढ़ रहे हैं, तो it's not just that हमारा जो potential और kinetic है उनके बीच में हो रहा है. Some energy is also being lost, right? And
Lost to the
that
environment.
is right. Lost in the environment, right? वो हम consider हमको करना है later. I mean, we have to mention that. But अगर मैं इस पूरे system को उठा के vacuum में ले गई तो क्या होगा?
It will just keep on going because there will be no forces, other forces that act on it.
there is no friction,
no air resistance,
no
no
air
friction.
resistance.
It'll
So
just keep going between gravitational, potential, and kinetic.
excellent.
I think we had a similar concept when we had done one project on making a Newton's cradle last year.
Yeah.
Okay.
So we had similar questions our physics teacher asked us based on like this.
On pendulum?
I mean, the Newton's cradle. So then someone answered that energy will be lost as like the sound energy of the marbles hitting each other and all. And the vacuum part also, yes. So,
And you will see a lot of questions in the past papers also based on this. बहुत सारे questions अलग-अलग तरीके से पूछे जाएंगे आपसे in the CIE asks these questions. So your teacher must have picked up all the questions from there only based on energy. Right? So हाँ, because वो concepts को clear करना बहुत जरूरी है. अब आते हैं useful energy and wasted energy. Okay, useful energy कौन सी energy होगी? Energy transferred to where it is required in the form of that is wanted. Okay, I want to utilize all my energy in running. ठीक है, तो जितनी मेरी एनर्जी रनिंग के लिए हो रही है उतनी एनर्जी आई एम रनिंग ऑन अ ट्रेडमिल मान लेते हैं. ठीक है, तो वो मेरे लिए यूजफुल एनर्जी जो मुझे हेल्प कर रहा है भागने में, दैट एनर्जी. बट क्या हो रहा है कि आज इट इज वेरी विंडी and I'm trying to run on a rocky mountain. ठीक है, compared to treadmill से हट गई मैं. I'm not on the treadmill anymore. Now I'm trying to run on a rocky mountain and it is very windy. सरगुन क्या होगा? What will happen?
You'll be like, you won't go that fast. You'll be really slow and you'll use like more energy.
I will be very slow. I will not be able to run. जबकि मेरे अंदर पूरी energy है. I have had all my food properly and I'm feeling very good and fit. Still, I'm not able to run. क्यों? उस तरह से नहीं रन कर पा रहे जिस तरह से मुझे मैं ट्रेडमिल पे रन कर रही थी. क्यों? गौरी?
You said it was windy, so maybe there's air resistance and friction acting on you.
And it's a rocky mountain.
And you're at a higher height. So you have a sort of gravitational potential energy, but not as much kinetic.
So I'm going against gravity, तो मेरी energy वहां लग रही है.
Yeah.
Plus it's not a smooth road, it's rocky. तो मैं उसके ऊपर रन करने की कोशिश कर रही हूँ तो मेरे लिए और मुश्किल हो गया. Because my energy is not it is being wasted in a lot of other things, like overcoming the air resistance, overcoming the friction, overcoming the gravitational force. है ना?
Yeah.
Right? So मेरा wasted energy बहुत ज़्यादा हो गया. Then I come back the next day and I'm again running on the treadmill. तो मेरी energy कहाँ waste हो रही है? सिर्फ friction को ही overcome करने में. The room is AC, the gym is AC. तो मेरा को ऐसा कोई air resistance ज़्यादा कुछ मिल नहीं रहा as compared to what I was on the previous day, what I was facing.
Yeah.
So you understand what is useful energy and wasted energy?
Yeah.
Correct. Okay. Now wasted energy कहाँ चली जाती है? वहाँ कहाँ जाती है ये सारी?
Into the environment.
Into the surrounding, right? Into the environment. Okay. अब जब भी इसका आंसर हमको लिखना है wasted energy, तो हम या तो वो फ्रिक्शन को ओवरकम करने में, जैसे इस केस में फ्रिक्शन को ओवरकम करने में, या लेट्स गो बैक टू द पोल वॉल्ट क्वेश्चन. देखा था ना हमने वो पोल वॉल्ट क्वेश्चन, राइट? सो वी लर्नड हाउ द एनर्जी ट्रांसफर हैपेंस, राइट? एनर्जी ट्रांसफर कैसे हो रहा था उसमें?
So first of all, the person had a store of chemical energy. Then when they started running, they had kinetic energy. Then because of the pole, they had elastic, like the pole had elastic energy.
Potential.
Yeah, potential. And then after that, they reached a height. So that energy was converted to gravitational potential energy.
Right.
And then once that person landed on the mat, we discussed about the elastic energy of the mat, as well as like the heat energy.
And one more energy, that sound.
Sound energy. The sound
energy.
of him falling into the mat.
जब भी हम spread out into the environment वाली बात करेंगे, तो लास्ट में मैंने आपको 2-3 पॉइंटर्स दिए थे. वहां पर हमको क्या आंसर करना है? साउंड, अगर मैट कुशन्ड आइटम है कुछ तो इलास्टिक पोटेंशियल, और अगर इट इज साउंड एंड हीट, ये दो तो आंसर होंगे ही होंगे आपके, साउंड एंड हीट जरूर होगा. समटाइम्स यू ऑल्सो राइट लाइट.
When there's a lot of heat.
हीट, जब ज्यादा हीट हो जाए, जब लाइक फॉर एग्जांपल टायर एंड रोड, तो वहां पर एक लाइट भी ऐड कर देना. और ये सारी एनर्जी क्या थी, ये सारी वेस्टेड एनर्जी है जो एनवायरमेंट में चली गई, यूज नहीं हुई. राइट, गॉट इट, राइट. ओके, अब आते हैं एनर्जी एफिशिएंसी. इसके बारे में भी हम ऑलरेडी बात कर चुके हैं. राइट,
Output over input.
इट्स ऑलवेज आउटपुट ओवर इनपुट. अगर एनर्जी का क्वेश्चन है, एनर्जी एफिशिएंसी है, सो व्हाट इज इट, एनर्जी इनपुट, सॉरी एनर्जी आउटपुट अपॉन एनर्जी इनपुट. राइट, आउटपुट वो होगा जो यूजफुल होगा, और इनपुट वो होगा जो आपने टोटल एनर्जी डाली है इसके अंदर. करेक्ट. ओके, व्हाट इज द बेस्ट एनर्जी, व्हाट इज द बेस्ट एफिशिएंसी?
Like 1 if your
One.
output is equal to your input, but that's
Output
not
is-
possible.
राइट, राइट. तो बट वन तो पॉसिबल नहीं है. सरगुन, व्हाट इज इट इन टर्म्स ऑफ परसेंटेज?
I don't know.
Arey, come on, Sargun. Are you doing something else on the screen? Tell me.
No, I'm on this only.
Are you sure? I don't
Yeah,
think so.
I was just fidgeting with the screen.
Fidgeting with the screen. क्यों?
I'm over here only, like minimizing and maximizing.
क्यों बेटा? Concentrate here because these are important things, right?
Yeah.
All right. बोलो. In terms of percentage क्या होगा आंसर? And all of these I have discussed already. It's nothing new. ये हम questions करते करते काफी discuss कर चुके हैं सरगुन. Percentage में क्या होना चाहिए इसका आंसर?
100%.
100%. Right. 100%. तो आता था तो फिर क्यों नहीं कर रहे थे आंसर?
Wasn't sure.
तो इट्स ओके, गलत ही होगा ना, क्या हो जाएगा? ठीक है, गलत आंसर भी दे रहे हो तो कोई बात नहीं, इट्स फाइन, बट यू हैव टू आंसर. स्पीक, यू स्पीक वेरी लेस, यू शुड स्पीक मोर. यू हैव अ लवली वॉइस. ओके, ऑलराइट. सो percentage is 100% and efficiency is 1. Now Gauri, what is the unit for efficiency?
There is no unit for efficiency.
There is no unit for efficiency.
In
Very
fact,
good.
the reasoning behind that is if you have the same units, they'll cancel out anyway.
They will cancel out each other.
Yeah.
So efficiency का कभी कोई unit नहीं होना चाहिए, याद रखना. हमेशा units cancel out होने चाहिए. So अगर एक ऊपर किलो जूल्स है और नीचे जूल्स है, तो convert everything to joules first ताकि units cancel हो सके, क्योंकि किलो जूल्स is not as same as the joules. Convert. Okay. अब आते हैं कुछ energy related. एनर्जी एफिशिएंट लाइट बल्ब्स. घर में आजकल पहले अर्लियर टाइम्स यूज्ड टू सी दोस येलो बल्ब्स, थोड़े पुराने टाइम पे येलो बल्ब्स होते थे, राइट? बट आजकल दे यूज दीज एलईडी लाइट्स, राइट? राइट सरगुन, व्हाई डू वी यूज एलईडी लाइट्स नाउ? डू वी यूज मोर ऑफ एलईडी लाइट्स फर्स्ट ऑफ ऑल, yes or no?
Yeah.
Why?
Because they're cost efficient and
Cost efficient and more importantly,
they produce more light energy.
they produce more or what? They produce more, किसी और तरीके से प्रेजेंट करो. Say it in a different way. They waste less.
Okay.
They are more efficient, right? They waste less, more useful energy. They are more efficient. Is it clear? ठीक है? Okay. And they are cost effective. चलो, अभी एक question. I want both of you. Sargun, read the question. You have to write it in your notebooks and give me the answer in the chat box. Sargun, read the question aloud.
Calculate the efficiency of an electric motor if it produces 48 joules of useful kinetic energy when supplied with 80 joules of electrical energy.
चलो, आंसर दो और चैट बॉक्स में देना पर्सनली टू मी. डोंट send it on the group.
Okay.
Okay, I've received both the answers. Okay, so in terms of number, just as an efficiency, if the answer is 0.6, you're right. But if you're converting 0.6 as a percentage, then it will be 0.6
60%.
multiplied by 100%, which is 60%. So, Sargun, you just need to put the percentage sign. ठीक है?
Yeah.
Okay. और अगर क्वेश्चन परसेंटेज में नहीं है तो एफिशिएंसी बिलो 1 होनी चाहिए. अगर जब तक आपसे पूछा ना जाए परसेंटेज में कन्वर्ट करो, you will not convert it. It's
I
not
think
needed.
I had written mine as a fraction.
You've
So
written as a fraction. That's also okay, but try to convert it as a number less than
decimal. Okay,
decimals.
I'll
Okay?
do that.
Read this. Now, Gauri, read the question. Again, answer
Calculate.
the chat box.
Yeah. Calculate the useful light output of a light bulb of efficiency 0.2 when it is of an electric motor if it's supplied with 400 joules of electrical energy.
Here, efficiency is given to you.
Yep.
You have to give the answer. तो ये बताओ जो भी आंसर इसका होना चाहिए. Again, chat box. Do it in the notebook and chat box में answer. सरगुन जल्दी भेजो बेटा.
Yeah.
Miss,
Hmm.
can I go and just get a drink of water?
Yes, yes, yes. Get some warm water for you. Sargun, what happened? इतना difficult नहीं है question.
I was just getting confused. I got the answer. Should I give the working also?
Just give me the final answer. But
Okay.
what is it? How are you doing it?
Basically, you were supposed to do 400 into 0.20. You get 80, and then when you do select just a recheck, when you get like 80 divided, you do 80 divided by 400, your answer will be 0.20
Right. So 80 unit क्या होना चाहिए?
joules.
Joules. Very good. Okay. अब percentage निकालना तो हमें पता ही है. Percentage के लिए multiply by 100 करना पड़ेगा, right? So this question, calculate the percentage efficiency. Now, if you see the question is telling you to find the percentage. पिछले question में percentage नहीं बोला था. So don't give the answer in percentage. Here you have to give the answer in percentage. चलो.
Understood.
Miss, you're on mute.
Okay. Okay. Got both the answers. So here, answer is 12.5%. I think both of you got the same answer, right?
Yeah.
Excellent. I think we have understood. Chalo. This you take it as a homework. Take a screenshot of this.
Just 1 second.
Sorry, put the screenshot on the group
Okay.
that you have to come prepared with this in the next class. Okay, Sargun?
Yeah.
God bless you.
Yeah. 1 second, I'll just put it on the group. Otherwise, the screenshot will just go.
Okay, done?
Done. Done.
Okay. Now, since we're talking about efficiency, what are the ways in which we can improve the efficiency? Right? So, okay. So you need to either decrease, किस form में energy waste होती है? Heat, sound. These are the two things that we primarily discussed. Heat को reduce करने का क्या तरीका है हमारे पास? Friction reduce करना. Heat कैसे हो रही है? It's either due to friction या फिर any kind of resistance, right? So what kind of resistance? Electrical resistance or air resistance. तो अब आपको ऐसी चीजें सोचनी है जिससे कि you can reduce that thing, right? Friction reduce करने के लिए usually हम क्या करते हैं? Lubricate करते हैं, smoothen out करते हैं, ठीक है? So you lubricate using oil or whatever, like depending on क्या है, कहाँ friction produce हो रहा है, and you put it. जैसे दरवाजा है, दरवाजे में आवाज आ रही है. What do you put there? You put oil.
Oil.
So that it becomes smoothen out, right? And smooth हो जाएगा तो अपने आप heat loss कम हो जाएगा, right? And efficiency better होगी, दरवाजा better खुलेगा, better close होगा. Electrical resistance in electrical circuits. अब उसको reduce करने के लिए आप किसी भी तरह का resistance अगर होगा तो वो reduce करोगे. उसके तरीके हम electricity chapter में पढ़ेंगे. And air resistance reduce करना है तो usually अगर आप देखोगे हमारी cars, हमारी the aeroplane, the ships, they are all made in a streamlined manner, right? They have a streamlined shape so that they can cut through the air, correct?
Yeah.
How do we reduce the sound? So अगर कोई भी ऐसी parts है, machine है, कोई भी ऐसे parts हैं जो कि they're not properly tightened or whatever, जिसकी वजह से sound आ रहा है, so you can tighten those parts, right? ये है energy flow diagram. Sometimes they ask you to make the energy flow diagram. So what is it? There's an input energy, there's a device, and there's an output energy. This is एक portion waste हो रहा है. Input energy gets into this, output energy goes out, wasted energy is coming out of the system, which is not in the towards the output. Then here, what is it? Light bulb, electrical energy गया, light energy मिला, heat energy के form में कुछ wasted energy है इसमें. Bulb गर्म हो जाता है, right?
हाँ.
Wasted energy is heat energy.
Heat energy.
Microphone, sound energy, electrical energy. Sorry, ये उल्टा लिखा हुआ. Input is electrical energy, sound energy is the output, or wasted energy, heat.
Energy.
Okay. Then car engine, chemical energy is input, kinetic energy is the output, wasted energy, heat, sound.
And sound.
Sometimes, as I said,
In
sometimes-
overcoming friction.
right, which is light. तो कभी-कभी spark होता है ना, कभी Formula 1 racing देखा है? Ever?
Yeah.
कितने sparks होते हैं उनके tires में, देखा कभी? There's so much of spark in the tire, right? Because of
Friction.
friction. Okay. Photosynthesis, light energy, chemical energy, and the wasted energy is in the form of heat. Again,
Heat is like a wasted energy in many of them.
in all cases. Okay. Some cases you have sound, and some cases you have light also. But it's either it is heat, sound, and light. इन तीनों में ही होगा. Heat तो सभी cases में होगा. चलो अभी कुछ. Sargun, give me the first answer.
Will it be chemical.
इलेक्ट्रिक मोटर है, इलेक्ट्रिकल एनर्जी दी आपने, तो आउटपुट क्या मिलेगा? केमिकल कैसे मिलेगा? और ये इलेक्ट्रिक मोटर है, टेस्ला वाली गाड़ियां जिसमें आप फ्यूल डालते ही नहीं हो, आप बैटरी चार्ज करते हो, तो क्या होना चाहिए?
Kinetic. Sorry.
वहां फ्यूल होगा, केमिकल एनर्जी होगी, उसमें नहीं होगी. ठीक है, इलेक्ट्रिक मोटर है. ओके, नेक्स्ट गौरी.
Okay. Car brakes, and it's saying the main output energy is heat.
मेन आउटपुट एनर्जी इज हीट. इनपुट क्या होना चाहिए? कार ब्रेक है. सोचो, गलत होगा कोई बात नहीं.
And maybe kinetic because you're pressing the pedal and the brakes.
ओके, नेक्स्ट. अब आपको कोई भी एक डिवाइस सरगुन सोचना है जहां पर ग्रेविटेशनल पोटेंशियल एनर्जी कन्वर्ट हो रही है काइनेटिक में.
Mm, in like a roller coaster.
Roller coaster is a good example. Yeah. Okay. Roller coaster is a good example. Next. So anything which is falling down. So उसमें gravity. Roller coaster नीचे आता है, फिर ऊपर जाता है, फिर नीचे आता है. Right. So a roller coaster when it is coming down, है ना? तो उस टाइम पे gravitational potential energy kinetic में convert हो रही है. Correct? When it is going up, it is the other way around. Next, Gauri. Candle में क्या होता है?
Input
Candle
will
is
be
a favorite.
chemical.
Candle is very favorite of all teachers.
Oh. I think chemical.
Okay. Chemical to light. Sargun, generator.
Um, I think here is a chemical.
It is what?
I said I think here also chemical.
Okay.
It
So
could be kinetic.
हाँ. So depend करता है कैसा generator है. Chemical भी होता है, you're not wrong. Chemical भी होता है जब वो घर वाले generator होता है ना, उसके अंदर पेट्रोल डालना पड़ता है या डीजल या कई बार केरोसिन ऑयल डालना पड़ता है, so that you can वो बर्न होता है, फ्यूल बर्न होता है, जिससे ये जनरेटर यूजुअली गांव में होता है. सो केमिकल एनर्जी इज नॉट रॉन्ग, बट यू हैव टू मेंशन द स्मॉलर जनरेटर्स. जो बिगर जनरेटर्स होते हैं वहां पर एक टरबाइन लगा होता है, जो टरबाइन मूव करता है बिकॉज ऑफ द फ्लो ऑफ वाटर, राइट? सो देयर इट इज काइनेटिक एनर्जी. सो गॉट द आंसर?
Yeah.
नाउ दिस इज अ वेरी इंपॉर्टेंट थिंग. Many questions you will get on Sankey diagram. ये किया है स्कूल में भी? Have you started this Sankey diagram?
No.
It's an energy flow diagram. हमने क्या क्या सीखा था? Input, then there's a device, output, but wasted is given shown like this. So ये Sankey diagram, they ask you draw the Sankey diagram, या Sankey diagram बना हुआ होगा और आपको चीजें लिखनी होगी उसके अंदर. So you always remember whenever you're making a Sankey diagram, उसमें क्या क्या चीजें होनी चाहिए? There is an input, there is an output, and here it is the wasted energy. Okay, so it's a flow diagram, energy flow diagram that shows how a device uses the energy. The width of the flow of arrows is proportional to the amount of energy. Okay, so if you look at the input, bada dikhaya hua hai,
Yeah.
right? Input is always bigger than the output, right? And wasted is smallest of all, unless output is less and wasted is more, but input se bada kuch nahi hoga. So the thickness, the width is very important when you're making the Sankey diagram. Clear?
Clear.
Wasted energy is always shown downwards. Never try to show it like this or this. ठीक है, हमें इसी डायग्राम में शो करना है, ऐसा ही शो करना है. So Sankey diagram में क्या दो तीन चीजें इंपॉर्टेंट है. First is what is the flow, input, output, wasted. Sargun, how is thickness important? सबसे थिक क्या होगा हमेशा?
Input.
इनपुट. फिर वेस्टेड एंड जो यूजफुल आउटपुट है, क्या वो दोनों बराबर होंगे?
No, useful is gonna be more thicker.
जनरली यूजफुल विल बी थिकर, बट ऐसा भी हो सकता है दैट यूजफुल आउटपुट इज लेस एंड वेस्टेड आउटपुट इज मोर. You
I
have
think
to
I've seen a diagram like that.
Yes, seen a diagram. Yes. Last year रहा होगा थोड़ा सा, little bit. ठीक है ना? Okay. Next. Draw a Sankey diagram for a car of efficiency 20%. Draw it in your notebook and show me. I'll just show you a sample here. Car. ध्यान से देख लो एक बारी, एक क्वेश्चन कर लेते हैं. Car. Chemical energy is the input. Chemical energy is the input. Car is in the middle. Input की thickness देखो. Output में जो कुछ भी चीजें हैं वो आप लिखोगे. अगर 2-3 outputs हैं तो वो भी लिख देना. Output इस केस में kinetic energy है primarily, और heat and sound के terms में loss है. अब यहाँ पर ध्यान दो, यहाँ पर efficiency is 20%, यानी 80% is wasted. So do you see that wasted is thicker than the output?
Yeah.
Clear?
Yeah.
Clear हुआ?
Yeah, and we need to measure the widths also accordingly.
Measure the width. आपको दिखाना पड़ेगा. So अगर आपने 1 सेंटीमीटर लिया है kinetic energy को, तो आपको 5 सेंटीमीटर देना पड़ेगा heat and sound को.
Got it.
ठीक है?
Yeah.
Okay. So I'll give you another question now since this is already drawn. Please draw a Sankey diagram for a machine which works at 30% efficiency. Instead of car, now it is a machine. And efficiency is 30%. And machine runs the conveyor belt. So it's a conveyor belt. Conveyor belt समझते हो? Conveyor belt समझते हो आप क्या होता है?
Yeah,
Yeah.
the ones in the airports.
Airports वाला, हाँ, very good. Sargun, you're not visible, beta.
Miss, I don't have a scale with me, so is it okay if below I just write how much the width, like
Yes.
change it will be?
Yes, it's okay.